Welcome, my friends. A matrix is just a set of numbers arranged in rows and columns that is sort of like a table of organized numbers. For example, A is a 3 by 2 matrix because A has 3 rows and 2 columns. B is also a 3 by 2 matrix. Because matrices A and B have the same dimensions, we can add them together component by component. The matrix A plus B is also a 3 by 2 matrix. The first entry is 3 plus 4. Then we have 5 plus 1, 1 plus 7, 6 plus 2, 2 plus 1, and 8 plus 2. When we add the two numbers together, we get 7, 6, 8, 8, 3, and 10, which make up the components of matrix A plus B. If two matrices don't have the same dimensions, they cannot be added together. Consider the matrices A and B. Matrix A is a 3 by 1 matrix, as it has 3 rows and 1 column, and matrix B is a 2 by 2 matrix, as it has 2 rows and 2 columns. Matrices A and B cannot be added together, as their dimensions are not the same. Matrices can also be subtracted, which works exactly how you would expect it to. Just like with addition of matrices, you need to have the same dimensions. Consider matrices A and B. Matrices A and B are both 2 by 3 matrices, so they can be added or subtracted. Let's find A minus B, which will also be a 2 by 3 matrix. We have negative 2 minus 1, 0 minus 6, 5 minus negative 3, 1 minus 4, 3 minus 2, and negative 1 minus negative 8. Simplifying, we have negative 3, negative 6, 5 minus negative 3, which is positive 8, negative 3, 1, and negative 1 minus negative 8 is positive 7. Matrices can be scaled up or down by multiplying the entire matrix by a constant. This is what we call scalar multiplication of matrices. For example, say that we have matrix A. Then 3A would be the same as A, except every entry would be 3 times as large. We have 3A, which is equal to 1 times 3, which is 3, 4 times 3, which is 12, 5 times 3, which is 15, and 8 times 3, which is 24. We could also scale a matrix down by multiplying by a fraction. 1/2 A has the components 1 times 1/2, which is 1/2, 4 times 1/2, which is 2, 5 times 1/2, which is 5 halves, and 8 times 1/2, which is 4. We can also have linear combinations of matrices too. Say that we have these matrices, A and B. We can find 3A plus 2B by multiplying each component of A by 3 and adding it to 2 times each component of B. We have 3 times 1 plus 2 times 7, then 3 times 4 plus 2 times 5, then 3 times 5 plus 2 times 2, then 3 times 8 plus 2 times 0. 3 times 1 is 3, and 7 times 2 is 14, so we have 3 plus 14, which is 17 in the first entry. 3 times 4 is 12, and 2 times 5 is 10, so we have 12 plus 10 is 22 in the second entry. 3 times 5 is 15, and 2 times 2 is 4, so we have 19 in the third entry. And 3 times 8 is 24, and 2 times 0 is 0, so we will have 24 in the final entry. Alright, my friends, that wraps up our video on matrix addition, subtraction, and scalar multiplication.